My name is Nandita Mitra, and I'm presenting my final project for Advanced Big Data Analytics E6895 in Columbia University. And the name of my project is Optimized Personal Investment Strategy. Thank you for taking the time to listen to my presentation. So here's the description of the project. So this is a part of a robo-advisor that tries to optimize personal investment strategy based on user input. Markowitz portfolio optimization theory was implemented in Python to achieve this. It was a version of Markowitz portfolio optimization. And the user will provide the input about what's the amount of money that he or she wants to invest, and what's the desired return, and what is the time for this return. And it will try to optimize a portfolio for that user. To optimize the portfolio after n years, we needed n-1 years of data. So I used simple linear regression model to predict the prices for the next 30 years. And this was also considered in the optimization task. The idea is that there will be another system which will provide this information, this future stock price, predicted future stock price for my system, but I couldn't get a hold of a system that can do that, so I ended up trying to predict the prices on my own. I did talk to a couple of other groups which are doing some work that seemed like can be used for my system, but once I looked carefully into it, one of the projects was dealing with only Bitcoin, but my project is dealing with more than one stocks, and I'm capturing the stocks from NASDAQ, so I decided not to use that. And another project was predicting the next day prices, next day trend for a stock. So they will predict if the stock price is going to go up or down, but I needed exact number. So again, I couldn't really use it without making some changes to it. But I will mention later on that I have provided a code segment in my system where we can use an API from something similar to the systems I just mentioned and try to feed it into my system and see if that will work. Of course, we may have to change the format and stuff like that to get it to work properly. Moving on, this is my system architecture. So I have a database that contains the list of stocks and stock price history, and now it also contains the future stock price, predicted stock prices. And my portfolio optimization backend either talks to the database, and if the data is not there, then it goes out to the Yahoo API and put the data back into the database. And then use Python libraries like CVXOPT and NumPy to achieve the optimal allocation and try to implement Markowitz theory to do that. And the user is using a front-end server that will let him or her to put his inputs, and I am using Python Flask to do. So here is my database schema. I have 4 tables. The predicted return holds the future predicted prices. The stock returns holds the historical prices for stock. And then I have a stock category, which where the stocks are divided into category with category ID and category name. And then system stocks has the stock ID, the symbol, the company name, and the category. Here's an example of my future stock price prediction. So I'm using linear regression model considering all historical prices of a given stock. So 12 data points per year from year 2012 to 2016. So I look at all these 60 points and then try to predict the stock prices for next 30 years. And here's an example of the predicted stock price for Amazon. As you can see, it seems like Amazon stock will be going up, and in 2026 it will be 1750. And I chose my 1,000 stocks based on the fact that all of them had a PEG ratio which was greater than 0.5 and a PE ratio that was greater than 0. And this is a flowchart that shows how I'm computing the average return for a stock symbol. So if the yearly return is not in the database, then I go and look into a cache file for historical and future prices, and if that's not there, then I go out to Yahoo API to get the information about the stocks, and then I write them back into the cache and also store them in the database, and then I can compute the average return based on the yearly returns. I'm using 1,000 stocks, so that makes the size of my covariance matrix a million. So to handle this large number of data, I decided to divide all the stocks into manageable size categories, and I looked at NASDAQ and picked the categories that it uses. And I'm doing the computation in parallel in all those categories, and if there is a category that is very large, then I compute it in multiple threads inside it. And these are my 11 categories, and the way I divide the money is investment in a category will be total investment multiplied by number of stock in a category, and then divided by the total number of stocks. This picture again shows how I'm doing the computation. So I have my 11 categories, and then I am doing the computation in each thread, and I wait till all the computation or all the threads are done, and then I output the optimization by categories. So page 10 shows a comparison between my previous system and the current system. So till this final version, I was using historical stock prices to do the portfolio optimization, but now by doing the linear regression model, I have some predicted stock prices, and now I'm using that with the historical stock prices to do the optimization of the portfolio. Here is an example of my project output. So the user provided me with the investment amount of $10,000 and expected return of 5% and 25 years. And I captured part of my system's output, and this is the suggestion it's coming up with in the category of transportation and finance. Here is I'm talking about some of the future extensions that can be made. So there is a function template in the code that can be implemented to use an API that provides future stock prices. The stock returns are then inserted into the database to make available for the portfolio optimization. So the name of this function is obtain and store future returns. So it can take API URL, a stock symbol, start year, end year, and the number of future years as its input, and then can store that data. If there is no API, then we can learn other models using historical stock prices to predict future prices. So I think with this we can try to use another system's output as an input of this system and come up with the optimal portfolio solution. So at a high level, I tried to come up with a system that can predict future stock prices on a large number of stocks and can perform a version of Markowitz optimization based on user input, and then provide the user with a front-end server where he can see what's the optimal portfolio will be based on his or her input. So these are the references, and thank you for your time and listening to me. It was a fun semester. I learned a lot. So thank you.